When we are talking about shifting, reflecting, and stretching graphs, we're going to use those 9 toolkit functions that we learned in the previous videos. And we're going to shift them and stretch them and shrink them and reflect them. So let's start with shift. Any value that's subtracted from x is going to cause a horizontal shift. And any value subtracted from y is going to cause a vertical shift. Now, that's an easy way to express it. In our textbook, they also write it using these 4 statements. Let me show you how these are the same thing. All right, for instance, look at this guy right here. Y is equal to f of x minus c. You can see that what's being subtracted from x is a positive c. So that would be a horizontal shift of a positive c. And so positive numbers on the horizontal number line, positive numbers go right and negative go left. So you can see c units to the right. That means the same thing. Look at this next one. If you had x plus c, that's the same thing as x minus a negative c. So if you say what's being subtracted from x, what's being subtracted from x is a negative c. So that would be a horizontal shift of a negative c. On the number line, negative values go to the left. Another way you could think of that is when we say what's being subtracted from x, subtracting is adding the opposite. So the other thing you could do is you could think of this as the opposite of whatever this is. So the opposite of negative c is positive c. The opposite of positive c is negative c, and that tells you what your shift is. All right, look at the next one. So for the next one, we've got y is equal to f of x plus c. Notice that that c is not attached to the x. We could easily subtract it to the other side. Unlike down here, that c was attached to the x in the parentheses. It couldn't be moved. So if that c can be subtracted to the other side, that value is being subtracted from y, not from x. So what's being subtracted from y is a positive c. And on the vertical axis, positive numbers go up. So that would be a vertical shift, c units up. All right, then for the next one, we've got y is equal to f of x minus c. So let's add c to both sides. And again, if you have y plus c, that's the same thing as y minus a negative c. What's being subtracted from y is a negative c. So that would be a vertical shift and negative numbers go down. So that'd be a vertical shift down c units. So again, you can use these 4 properties, or you can just use these 2 statements to do the same thing. So let's look at some of these. All right, so to begin with, we've got y is equal to the square root of x. We should know what that looks like. That's one of our toolkit functions. And so if you notice, the only difference in the equation, y is equal to the square root of x and y is equal to the square root of x plus 1, is this plus 1 right here. Now, can that 1 be moved to the other side? No, it's stuck to the x. It's underneath the square root. It can't be moved to the other side. So that's how we know it's being subtracted from x. Okay, so what's being subtracted from x? What's being subtracted from x is a negative 1. X minus a negative 1 is a positive 1. So what's being subtracted from x is the horizontal shift, so that'd be a horizontal shift of a negative 1. Again, you could think of that as the opposite of, so the opposite of positive 1 is negative 1. So I'm just going to start at the origin, because that's where my graph starts. I'm going to start at the origin, and I'm going to horizontally shift a negative 1, and then I'm just going to draw the exact same graph. So our goal is to be able to draw these without needing to plot any points. All right, look at the next one. So for the next one, can this plus 1 be moved to the other side? Because that's the only difference between the original function and this new one. That plus 1 could be subtracted to the other side, right? So if it can, it's really being grouped with y, and that's a vertical shift. All right, so what's being subtracted from y is a positive 1. So that'll be a vertical shift of a positive 1. Again, you can think of that as the opposite of negative 1 is positive 1. So if we vertically shift a positive 1, again, we'll start at 0 and we'll go up 1 and then we'll draw the exact same graph. All right, look at the next one. So for this next one, can that 2 be moved to the other side? No, so it's stuck to the X. That's going to be a horizontal shift. Can this 3 be moved to the other side? Yes, so that one's going to be grouped with the Y. That's going to be a vertical shift. All right, so for our horizontal shift, what's being subtracted from X? A positive 2. So our horizontal shift would be a positive 2. For Y, we can subtract this 3 over to the other side so that we can clearly see it's being subtracted from Y. So what's being subtracted from Y? A positive 3. So our vertical shift would be positive 3. So we're going to horizontally shift a positive 2, vertically shift a positive 3, and draw the exact same graph. Again, you could look at this and say opposite of negative 2 is positive 2 and opposite of negative 3 is positive 3. Now, most of the time when they give you these equations as your problems, they're going to have Y alone on one side. And so you're welcome to move your vertical shift over with the Y to be able to clearly see it. But if you want to leave it where it is, notice that this would be X minus the horizontal shift, and then it would be plus the vertical shift. So I would do the opposite of this number, but I would use this number exactly as it stands. Okay, so again, you can move the 3 to the other side, and then you can say what's being subtracted from Y is 3. What's being subtracted from X is 2. So that's a horizontal shift of 2 and a vertical shift of 3. But if you want to leave it where it is on this right-hand side, just remember that you'll do the opposite of this number for the horizontal shift, but you will use this number exactly as it is, the positive 3. All right, let's look at some more of these. This time, they're going to give me the graph and ask me to come up with the equation. All right, so here's another one of our toolkit functions. That's the graph of y equals x squared. And so if we compare the original with B, what is the change that has transpired? Well, we've had a vertical shift down 3, right? So that would be a vertical shift of a negative 3. So now to write that equation, let's start with our original equation was y equals x squared. And to designate a vertical shift, any value subtracted from y is a vertical shift. So we would do y minus a negative 3. Of course, minus a negative is plus, so that would be y plus 3 is equal to x squared. If you'd rather, you can write this plus 3 on the other side, so it would have to be subtracted over to the other side. And so we could write it either of these ways, it would be the same thing. All right, look at C. If we compare C to our original function, what change has been made? Well, it has a horizontal shift of a positive 2. All right, so to write that equation, we're going to start with our original function. Our original function was y equals x squared. And again, a horizontal shift is a value subtracted from x. So we need 2 to be subtracted from x. Now, I need to be really careful here when I put my square on. Do I want to put my square right here on the x? Or do I want to have x minus 2 in parentheses and put my square there? I need x minus 2 in parentheses with my square there. Why? Because if I don't, if I write it this way, that 2 is not stuck to the x. It can be moved to the other side, and that would be a vertical shift of a negative 2 instead of a horizontal shift of a positive 2. So the way that I designate that as a horizontal shift, I have to attach it to the 2, whether I use parentheses or absolute value or square root, whatever the function is that I'm working with. All right, look at the next one. So again, if we compare to the original function, you can see that this one has a horizontal shift of negative 3 and a vertical shift up 1, so that would be positive 1. So to write our equation, we're going to say y minus the vertical shift, so that would be y minus 1, is equal to x minus the horizontal shift, and the horizontal shift was -3, so x minus a -3. Remember that I have to attach that 3 to the x, and the way that I do that is by putting it in parentheses before I raise it to the square. I can't say x squared plus 3. Of course, minus a negative is plus, so we could write that as y minus 1 is equal to x plus 3 squared, or if you'd rather, you can add that 1 back over here, and so you'd have y is equal to x plus 3 squared plus 1. So you can write it either way.